Welcome to the ISSA Web Conference, Secure Development Lifecycle for Your Infrastructure. Today's web conference is brought to you by ISSA. We would also like to thank ICSIA for their generous support of this live event. To explore more of ISSA's educational offerings and benefits, visit our website at issa.org. With 10,000 members in over 150 chapters in 70 countries, ISSA is committed to developing and connecting cybersecurity leaders globally. We thank our members for joining us today, and we encourage today's visitors to become a part of our growing community. During the presentation, please feel free to ask questions. To ask a question of the speaker, simply type your question in the chat area of your screen. You may need to click on the double arrows to open this function. If you are on Twitter, we hope you will join the conversation at #ISSA Web CONF. Within 24 hours of today's event, the presentation slides and a recorded version of the webcast will be available on the ISSA web conference page, as well as an email containing a link to the post-event quiz will be sent. After the successful completion of the quiz, you will be given the opportunity to print a certificate of attendance that you can submit for CPE credits in accordance with various certifying bodies. I am pleased to welcome our moderator for today's conference, George Orchias, Vice President, South Florida ISSA Chapter. George Orchias is author of Microsoft Windows 7 Administrator's Reference, holds a Master's of Science in Management Information Systems from Florida International University, leads the Advanced Penetration Testing and Vulnerability Assessment Quality Control teams in a large financial institution, and serves as Vice President of the Information Systems Security Association South Florida Chapter. George, please begin the presentation.
Thank you very much, and welcome everyone to the ISSA Web Conference, Secure Development Lifecycle for Your Infrastructure. We have heard a lot about the security development lifecycles throughout the years, but how do you do this, and how can you extend this throughout the enterprise? What are the changes that we need to consider? This presentation will discuss the lifecycle view of the network and how you can take advantage of the lifecycle approach through design, validation, and process management to secure your network today. I would like to introduce the speakers who will share their experience. Michael Angelo, Chief Security Architect with NetIQ, Harry Pandaya, Chief Advisor, Director at Strata Information Services, and Fred Koss, Vice President, Enterprise Marketing for ICSIA. Our first speaker, Michael Angelo, is Chief Security Architect with NetIQ. Michael is well known in the security community with his work designing, developing, implementing, and deploying security products and architectures for multinational corporate environments. His work includes participating, driving, and creating security standards, working on corporate policies, national and international legislation, and multinational regulatory issues. Michael is very active in the security community at large and participates in numerous international and national advisory councils. Currently, he chairs the ISSA International Webinar Committee and is a technology contributor to the U.S. Department of Commerce Information Systems Technical Advisory Council. He's also been a featured speaker in numerous national and international security conferences, including RSA, ISSA, and InfoSec. In 2012 and 2013, he was on the RSA National Symposium Committee. Michael currently holds 52 U.S. patents, with the majority being in the area of security and authentication. He's a former Sigma Psi Distinguished Lecturer, representative of the Trusted Computing Platform Alliance Lifetime Achievement Award. In 2011, he was recognized by ISSA as a Security Professional of the Year, and in 2013 received the ISSA Hall of Fame Award. So thank you, Michael, and please begin. Michael, you may be on mute.
Sorry about that. Nothing like talking into the mute. Okay, thanks, George. Greatly appreciated. The next slide, please. So today I'd like to talk to you about secure development lifecycle, and what I'm going to do is I'm going to lay a little bit of background provide some history, and then we'll talk about software SDL. So in general, secure development lifecycle can be applied to everything from software through to your infrastructure, through to your network, but most people just concentrate on software with it today. And with that, next slide. So, you know, security, there's one of these terms that we all sit around and talk about all the time. And, you know, every time I ask someone, what do you mean by security, I get an answer that, well, you know, we all know good security. And ultimately, security is like good food. Everyone knows about it, and everyone talks about it. And at the end of the day, you know, we sit there and still aren't sure. From what I look at as being security, we always talk about the analysis of the threats and provisioning of appropriate mitigations. So I know something's going to hurt me. How do I prevent it from hurting me? And just because I've got a solution today doesn't mean that that solution will work for tomorrow. Next slide. So what is a secure development lifecycle? Well, the goal of a secure development lifecycle helps people develop product and infrastructures and know that they're as secure as they can be. You know, we always have arguments about whether or not you can be 100% defect-free or secure, and at the end of the day, when we have these arguments, you know, we don't really know quite that we are in fact 100% secure or defect-free, and therefore we always have to monitor and work on it. Next slide. So the best way to develop security is not as a bolt-on, and we've all seen this in the past. Steve Lipner, who is one of the senior directors at Microsoft, used to always say the best way to implement security is part of the development lifecycle, and basically that's what Microsoft went off and did at one point in time. They completely rebuilt all their products and analyzed all the products and looked at it and said, okay, now we've bolted it on, now let's get security into the grain of building the product to begin with. Next slide. Part of the way that it was sold is not as, hey, we're doing security, but, you know, as a way to detect bugs, fix bugs, stop repeatable bugs. If you have less bugs, then you need less updates, which means that your product is more stable, your infrastructure is more stable, you have more time to add new code, which could be a new feature that improves customer satisfaction, or anyone who's using the product. When I talk about customer satisfaction of products, you know, everyone's a customer. Anyone who runs your program is going to be a customer. Anyone who has a you know, code that they're going to depend on is a customer, and if that code doesn't work right, guess what? You've got a problem. Next slide. So in normal SDL, Secure Development Lifecycle, there are 7 phases. Microsoft coined it originally. There was a training, a requirements, a design, implementation, verification, release, and response. And what's evolved over the past couple of years has been an agile version of it. I guess it's in keeping with the trends for agile, wherein there's training, and training is very, you know, down to the point. There's the specification, development, release, and response. Specification combines the requirements and the design elements of the actual product, and then implementation and verification is combined pretty much in the development phase. Next slide. So let's talk about training. Training, of course, should happen prior to starting any products or doing anything along that line. You know, there's actually a number of great resources online. There's the OWASP and SANS MITRE sites, and they, you know, talk also about, you know, all these common vulnerabilities that you will have in the product. We'll talk about that in a few seconds. We also train on what to do, or best practices. You know, don't use this call, use that call. If you have passwords, don't write them to the disk, you know, that sort of thing. Next slide. So if you look at the OAuth top 10 vulnerabilities, they're pretty much stuff we've seen in the past, everything from injection attacks all the way down to unvalidated redirects and forwards. And these have been the elements that have hit us over the past 3-4 years repeatedly. Just about every industry is getting pummeled by this. Next slide. And if you look at the SANS MITRE report, they've got 25 typical programming errors that people always make. Improper neutralization of special elements. You know, geez, did you take out the injection attack, the meta escape characters out of the commands, all the way down to URL redirections for untrusted sites? At the end of the day, these are about insecure interaction between components. Next slide, please. If you look at the next bunch of errors, buffer copying without checking size, and buffer overflows and integer overflows or wraparounds, this is all about risky resource management. And we can actually, we've known about these vulnerabilities or issues, errors, for years and years and years. Buffer overflows have been around since, I remember the first one I saw was in 1984 or 85 with the finger command from the old Unix environment. And it's all about making sure that if a resource is being used, it's being used correctly. The recent rash of OpenSSL issues, for the most part exist because of buffer reuse and not wiping. And of course, not looking at the size of the commands and the requests that are coming in. And well, won't go into those right now. Next slide, please. And then there's, of course, the authentication for critical functions. Just because someone says that they're authenticated and authorized for something doesn't necessarily mean they are. And how many times have we looked and we find someone's hard-coded credentials into code? It makes it a lot easier to use, but, well, not necessarily the best way. In short, these are what we term as porous defenses. Next slide, please. So, the number one coding principle that I've seen over and over again has been people don't validate the input that's given to them. You should always validate your user-controlled input. If someone can write code or give you input into your product or infrastructure, you need to validate it. If you look, OWASP has really got 5 of their top 10 are attributed pretty much to the user-controlled input and needing to validate what comes into the package or into the infrastructure, the code stream. 14 of the 25 MITRE are the same thing. One of my old friends used to always say user-controlled data or user-controlled input is attacker-controlled input. Assume it's going to be breaking into your system. Assume it's going to be something that's going to come around and bite you if you don't check it. This can mean checking the size, the type before you use it. How much data am I requesting? Just because someone puts in hello world doesn't mean that they should be able to get back 5K of information from the program. Make sure that you check encoding of the program. So if someone goes and writes something in UTF-8 or 16 and you're only expecting ASCII text, you might have a problem if they put in meta escapes if you're not checking that. And by the way, if you're going to take a file from someone that you're going to parse, you also need to go and make sure that that file is correct as well. And then there's the server. Just because you authenticate on the client doesn't mean that you're good on the server. How many times have we seen people write code that will go and generate an input stream into a network connection on a server, and it's all, bad stuff. Next slide, please. So, of course, the top one is going to be validate input. The second one that we typically see is people will tend to ignore compiler warnings. If you write a program and you get a warning, there's a reason you got the warning. It's not because someone wanted to give you something to read, but it's probably because there's something wrong or potentially wrong with the way you wrote the program. It's always tough if you look at people's compiler warnings and say, guys, you missed this, you missed that. And they go, but, well, it's a warning, and it's a bad thing. So that's one of the things I see people miss a lot. And then, architect and design for security, of course, keep it simple. Some of the most complex, coding I've seen has been some of the most complex bugs I've seen. Just say no, always a good thing. Default deny, and then loosen up accordingly. One of the things that I've found, and I know this will sound funny, is if you've got a large team of people working on a program and everyone has their own coding style, it can become cumbersome. So adopt a coding style. Don't use this call, use that call. I'm not necessarily talking about putting the curly braces on the same line as controlling arguments or breaking them off differently. I'm talking about things you actually do with respect to the code. For example, don't use a mem copy, maybe use a safe mem copy, etc. Next slide, please. So we've trained about software and we give people information about how to do software properly. The other thing is policies. We all have guidelines and policies and best practices, and guidelines are things that are we've read or heard, but no one really follows them because there's no enforcement, and the best practice is something that we should do, because when we didn't do it the last time, we wound up getting hurt or something bad happened. A policy is something we must absolutely do. We don't have any control over a policy other than once it's written, how it's enforced. So if you look on the next slide, here's an example of a policy, passwords. Don't store your passwords in the clear. Why don't you store your passwords in the clear? Well, if you store your passwords in the clear, someone's going to find it, and therefore your program's compromised or your infrastructure is compromised. A best practice that could be a borderline policy is don't write your own encryption. Use FIPS 140 validated algorithms. Use standard encryption. I don't know about everyone's infrastructure out there, but cryptographers in my world are hard to come across and hard to find. And then there's this problem with interoperability. Oh yes, that's a great algorithm you wrote, but it doesn't work with anything else. Another thing we do as an optimization is, we tell people don't compile their own versions of source code. If you've already got OpenSSL in your infrastructure, don't recompile it. So, don't do extra work if you don't have to. Use that work to go clear up warnings and errors that may appear in your code. Next slide, please. Just as a recap, we've all probably seen a policy is always a simple statement, one statement long, not paragraphs and pages of information. So the policy is passwords must be stored in plain text, not be stored in the plain text. Then there may be some additional information in the policy document, such as background or an explanation as to why you shouldn't do that. And of course, you need definitions. Some people don't know what plain text is or know what some of the fancy terms are, so you make sure that it's plain and clear and understood. And then, if there's a question and you don't identify who's going to answer that question, well then, the policy may not be well understood. And of course, just because there's a policy doesn't mean that there's backing behind it. So you want to know who's going to enforce it or be the sponsor, and then what's the penalty for not doing it. In general, policies don't change. The procedures associated with the policies will change. The policy itself will either exist or go away. Next slide, please. Now we talk about phase 2, the specification, secure design. That's where we talk about the features and what's going into the product and how is it going to be used. And they should follow the policies and, of course, best practices. If I'm going to go say, here's a sensitive data we're going to get in, well, sensitive data, when we're talking about it, we probably would say, okay, we need to include some encryption here in the actual design. And once you've got the specification and the design down pat, then you want to do a threat model and say, hey, are we introducing any errors in the infrastructure? Are we introducing any potential problems in doing this? And if so, what are we going to do to mitigate them as we're designing the code? Next slide, please. So if you look at the picture on the left, this is actually someone's design, and it was, basically we need secure entry, and yes, they get the checkbox of the secure entry. In reality, the picture on the right, no one pays attention to it. They just go around it. This is poor security design. It stops maybe 1 or 2 people, but not a lot. Next slide, please. So, why threat modeling? It identifies the attack surface. How are we going to get exposed? Where might we get exposed? What might be exposed? And it helps us provide a security objective. If this information was exposed, that would be a bad thing, and therefore we need to go and protect it. And in general, it helps minimize any exposure. We don't have to go back and retool or rebuild. Next slide, please. So if you think about a threat model is broken into 3 real pieces. It's the risk analysis, i.e. what could be bad, the impact analysis, how could it go bad, and what would happen if it did go bad, and the mitigations. Okay, how are we going to stop this from occurring? In general, we like to do threat models when a new feature is defined, i.e. we want to go and turn the lights off in the building, or we want to be able to change the thermostat in the house from out on the road. And therefore, what is the threat going to be? So it's important that when we define a new threat or we determine a new feature, we can say here are what the threat is. In general, when people start off to develop something, the end result is not exactly what they were going for. It's evolved over time. They enhance it, and they change this, they change that. And therefore, the threat model may not still be relevant. You may need to actually tweak the threat model. And you really want to do this before code freeze, because if you discover a problem in the code and you can't change the code because it's ready to go out the door, or it's ready to be sold, or it's been sold, makes it really tough to fix it. You have to go back and update it. Next slide. So again, the 4 components. When I like to see a threat model, I like to know what is it I'm looking at. So there's information about what the threat model is, what the product is, or the thing is I'm looking at. And, are there files, permissions that I need to worry about? How is it protected? Information in general that you can later go back and point out and say, yeah, here's a communication path. This is how this works. And yes, we're not worried someone's going to go and attack it. I still use the old STRIDE, spoofing, tampering, repudiation, information leakage, denial of service, elevation of privilege, to do my risk analysis. Is there a spoofing attack? Is there a tampering attack? Can someone go and do something and I can't deny that they did it or prove that they didn't do it, or they can deny that they did it and prove they didn't do it? What's the impact? Okay, just because there's a risk doesn't mean that you want to necessarily mitigate it. If it can't destroy anything, it's not going to be exploitable. It's not going to affect users. Do you really need to mitigate it? And then the mitigation based on what the impact analysis is with the risks in mind. Next slide. And then during development, just because you've done the threat model and you figured out in advance what you're trying to build, and you've had all this training, you still have to pay attention to the simple things like the compiler messages. You still need to do code reviews, do automatic ones, and do manuals as well, particularly if there's an information assurance component to what you're doing. From a security analysis point of view, you really want to go back and revalidate the threat model before you get to the end of the product. Oh, we're not doing this feature anymore, and therefore that whole threat line there just doesn't make sense. There are scanning tools and testing tools you can use, and there's even hardening guides, things to actually go back and clear up. Next slide, please. So if you look at development tools, there are tons of tools out there. Go out to Wikipedia. There's a list of tools for static code analysis. There's all kinds of tools for profiling and reconnaissance, looking at the product after the fact, There's tools for doing exploits and fuzzing being writing malformed inputs, which helps you with your validation of input. And then there's all kinds of scanning tools which will tell you maybe this is a vulnerability or maybe it isn't. Next slide, please. Just because the item went out the door doesn't mean your security work stops. You still have to perform periodic testing. You still have to monitor CVEs and threats and everything else that's there. And you may even want to go and get the products certified. If you don't test after release and someone discovers a vulnerability, or you're not tracking CVEs and threat boards and someone discovers a vulnerability, there is an issue. And just because the people that built it didn't find an issue doesn't mean there won't ever be an issue. Certifications are important in terms of the product. Is it, common criteria certified? Is it FIPS validated? What did you do to have third parties look at the product afterwards or during to make sure there isn't a vulnerability? Next slide, please. SDLC is in fact constantly evolving. It's not static. It's not pure engineering because the usage models change. The tools are changing as things get and people get used to them. They're evolving. Our knowledge is evolving, and so is the method of communicating the knowledge. Next slide, please. Some quick pointers to resources, and yes, the slides will be posted at the end of the webinar. Within, I think, 24 hours they get posted. So some pointers here that you can look at. Of course, Microsoft with their SDL, OWASP Top 10. Department of Homeland Security has also done a lot of work with software assurance. Next slide, please. And that's it. Thank you.
Excellent. Thank you very much, Michael. As a reminder, you can submit questions through the GoToWebinar control panel. One of the questions we have here for Michael, the question is, why did you mention threat modeling in the specification and development phases instead of other things?
Yeah, when you specify what the product's going to do, you have certain assumptions that you make about the threats, the things that can go bad, the things that could go wrong, the things that might go wrong. When you've actually developed the product or the infrastructure or deployed it, you suddenly realize that things are changed from what you actually built threat mitigation against. And maybe there's something that you added in there, that last-minute feature that you didn't put in the threat model, and you need to go back and really look and say, okay, is this going to create an exposure? Is there anything bad that can happen? Is there a spoofing attack against it? Could someone go in and grab information? Could I have a PII leakage from it? And therefore you really want to do it twice. Once when you talk about what you're going to build, and once when you actually have, in fact, built it, to make sure that you've closed all the holes and corrected all the gaps.
Excellent. Thank you very much, Michael. As a reminder, you can submit questions in the panel, and we will get to your questions are submitted now at the end of the presentations. Now I would like to introduce our next speaker, who's Harry Pendala, Chief Advisor and Director at Strata Information Services. Harry has 19+ years of experience in information technology. Harry is currently the CEO of 7InQ, a startup accelerator based out of India. He's Director and Chief Advisor for Strata Information Services, and information security services company servicing the ASPAC region. Harry is a CISSP, CISM, and ITIL version 3 certified professional, and is an ISSA fellow, currently serving as president of ISSA India in Bangalore. He's also president of Tirupati Information Technology Association. Harry has served as board member in Silicon Valley ISSA in various roles from 2004 till 2009. He thoroughly enjoys mentoring K through 8 kids about robotics and other science topics. He has a master's in computer engineering from Florida Atlantic University and a bachelor's in electrical and electronics engineering from SB University in Tirupati, India. I'd like to turn this over to Harry, and thank you, Harry, for being here and presenting.
Thank you, Jorge. So Michael covered basically what is SDLC and what you need to do with respect to SDLC. My background is as a security practitioner and auditor. I go to a lot of companies to do compliance audits, and when I go to developers and talk about SDLC audits, and we frequently find a lot of repeated issues. So today my topic, I'm going to talk about mostly frequently found issues during audits and recommendations and the challenges that usually developers teams have. Next slide, please. So I kind of broken the issues into domains, and the first one is access control, source code management. It's with today's technologies and with open source ones and the commercial ones that's available, it's easy to do access restrictions. But we generally find there are no or minimal access restrictions to the source code, especially developers who have left the company, they still have access, and also people who need not to have access to the source code, they have access to the source code. And the second one, what we see is no source code backups. It's very interesting, and the cost of backups has gone down drastically, but we still see the backups are not being done appropriately. And also unrestricted access to the backups. Backup administrators, if the backups are not encrypted, backup administrators might be able to, restore the backups to some other computer, and they'll get access to the source code. And the other issue is release management. Like especially small companies, they have like 10 or 15 people, developers, but they don't have a specific person doing releases. So what happens is in these small to mid-sized companies, we see developers wearing the hat of a release manager. So there are issues with that. It is difficult if you don't have proper audit controls or auditable controls in place. It is very difficult who rolled out what, when, why. So my recommendation is to have auditable controls in place and to see kind of dual control, right? So find somebody else other than the developer team to provide access to the developers whenever they are doing the release. Next slide, please. Information security governance and risk management, personal security, lack of background checks. Like in today's world, there are a lot of third-party vendors doing development for your product. And those vendors, they may not have done background checks appropriately. You assume, the majority of the times what happens is the company that is giving the project or the code, they assume that background checks are being done. So you have to do, or your information security team they have to do the due diligence and ensure background checks are being done on the personnel or developers that are doing the development. Awareness and training. Michael mentioned training is very important. Non-existent SDLC training and SDLC process orientation. So when a new developer comes onto the team, ensure that person goes through your SDLC process orientation, and then on an ongoing basis have some training provided by like sites like OWASP, or get a trainer and give annual training or refresher training to your developers. And also no security awareness. Somebody was mentioning this morning, so it's easy to teach security to a developer rather than the other way. So ensure all your developers go through security awareness and training. Next slide, please. Software development security. I mean, there is no, in some companies we have seen no formal policy. When I ask for, okay, where is your copy of SDLC policy, they whip up something and give me like 2 pages. So there is no formal policy. If policy exists, but it lacks enforcement. And lack of security testing, and you have to ensure all your developers do security testing, and also your QA team allocates some time to do security testing. Like Michael mentioned, there are a lot of freeware that's available, and it gives you, they find 80% of the issues with your code. And the other thing we found is production data is being used for testing, and no production data cleansing or improper cleansing happening. So ensure no production data is being used, even if you are, there might be some scenarios where you are forced to use production data, but in those scenarios, ensure data is cleansed properly. In the cryptography domain, developers save the keys in plain text, and they have full access to crypto keys. You have to develop your own process, ensure developers, they don't have access to crypto keys, which they can see it. And improper implementation of cryptography, like Michael mentioned, ensure don't develop your own cryptographic algorithms and use that's already available out there. Next slide, please. And the other thing is in operational security, no change management process. Ensure your developers, whenever you're rolling out new features or updates or patches, ensure they go through change management process. So even if an auditor finds one feature or one patch that has been applied to the code without proper change management, it would create, it raises a big red flag. So ensure all the tickets that has been rolled out, all the patches that has been rolled out have appropriate tickets. And also no incident management process. So when incident happens, developers are involved to identify how the incident happened. So developers, they need to be aware of the incident management process, and they need to get involved in the incident management process. Physical security, unauthorized access to code, because code is downloaded to a developer's laptop, and the documentation is lying around on the tables. Ensure access to the code is restricted and appropriate controls are in place. And during audits, and also the companies, you have to conduct your own internal audits before requesting a third-party audit to come and do the audits. So do your own internal audits. I request your information security team, hey, we need help in doing an internal audit. They should be able to help you. And no outsourced vendor audits. So like similar to background checks, you need to ensure you request your information security team or find a vendor that can audit your vendors if they are offshore. No audits of cloud-based SDLC tools. I mean, nowadays, there are a lot of open source, free SDLC tools or applications available. Be aware, ensure you'll be able to audit who has access to your source code. Next slide, please. So coming to recommendations, adopt one of the following maturity models. There are a lot of maturity models that come out of Carnegie Mellon. These are some of them, and ensure follow one of the maturity models. Sometimes it is highly difficult for small to mid-sized companies to adapt to any of the maturity models. Pick and choose, nothing wrong. Pick and choose that is suitable for your company, and then you can grow on top of it. And static analysis, Michael mentioned. So there is something called Safe Code where they have a lot of guidelines on how to do static analysis and things like that. Next slide, please. Application security testing. WOAS testing guide, they recommend 9 types of active security testing. So these are the list of testing. You can go through a WOAS website where you can find what kind of testing need to be done at what stage and whether it's applicable. Like, for example, if you're developing a multi-tenant application or a product, how to do multi-tenant testing to ensure one tenant is they cannot access data for other tenant. Next slide, please. Monitoring and logging. This is something what we find usually. For our auditors, if something doesn't exist in black and white, it doesn't exist for them. So ensure monitoring and logging is being done appropriately. Log all of your audit findings, whether it's an internal audit or external audit. Peer code review findings. A lot of times peer code review happens, but the findings are not logged or attached to the ticket. Security testing findings and logging of application access. Majority of the times when you develop applications, developers they don't try to keep track of application access. So this is kind of important for the security of your product. And I know you hate this, but engage information security team early in the development life cycle. So they can guide you and they can, and if you engage them early in the process, the total cost of development of the product goes down drastically. Next slide, please. Challenges, application security to ever-changing development environment. I mean, example right now, mobile app development. I mean, like, what kind of SDLC can I follow for mobile app development? Because mobile apps are being developed by an individual or like 4 or 5 people, teams, and they are releasing that product, within days or if not hours. So how to apply security to this kind of environment, ever-changing environment. So this is one of the challenges that we face as a practitioners and as an auditors. Next slide, please. So that's it for now from my side. And if you have any questions, please go ahead and ask.
Excellent. Thank you very much. And we are seeing a couple questions come in. I will leave some for the end, but do have one here in relation to the mobile app development. And it's what kind of SDLC model is suitable for mobile app development?
Well, because it involves, since mobile app development is a short period of time, like kind of iterative development model. Iterative model would really, it is suitable for mobile app development, where what happens is you develop and you test it, and then you release, and then you get the user feedback, and then you develop and you release. So you go through those cycles.
Excellent. What is one thing you recommend to have a secure SDLC process?
Well, engaging information security early in the development life cycle. I know a lot of people, a lot of developers don't agree with me, but I've seen time and again in companies where I have worked and where I have been an auditor, companies that engage information security on a regular basis, on a periodic basis, their product, we found their product is much more secure than the other.
Okay, excellent. I'll do one more question and then we'll move on. And that is there any rule of thumb for cost of developing a secure development lifecycle?
Michael, maybe this is your
So
expertise.
it's not the cost of developing it that you worry about. It's the cost of when things break to your credibility, as well as other legal costs and things that can go wrong. So, the cost of doing it at the beginning is in your training, which you really want people to write properly, and then in terms of their testing, which you really want to test properly anyway. So, the cost is not really what you would think it would be.
Excellent. Thank you very much for that answer. So it's more of a cost of not having one, and a future cost, and not only monetary but also a reputational one. So that's a great point that you made there, Michael. Thank you. And thank you, Harry, as well. I will now introduce our next speaker, who is Fred Coast, Vice President, Enterprise Marketing for Ixia. Fred is the Vice President of Security Solutions at Ixia. He is responsible for managing and marketing the Ixia security and applications portfolio. Fred has a passion for security and has been involved in information security for most of his career. Prior to Ixia, Fred was head of product marketing at Checkpoint Software. Fred has over 15 years of experience in the information security field and speaks frequently on information security. He has also held leadership positions and has extensive experience in security with companies such as Cisco, Symantec, Encircle, Blue Lane Technologies, and Recourse Technologies. Fred holds a Bachelor of Science in Electrical Engineering from Purdue and an MBA from Keenan Flagler Business School at the University of North Carolina. Thank you, Fred, for presenting. I'm turning it over to you now.
Thanks, George, and thanks everyone for joining today. A lot of talk about the software aspects of a development life cycle, and what I want to do, at the end of the third session here is really think a little more broadly to include infrastructure. We've seen some very, well-developed secure development life cycles from folks like Microsoft, which Michael talked about earlier, where they put a big focus on, finding bugs in products and fixing them to the betterment of security. But even organizations like Cisco has a well-developed secure development life cycle where they're pursuing, getting bugs and vulnerabilities out of their products. And so it really has become a best practice, lots of templates and tools from not only these two vendors. But one of the challenges is a lot of these bugs are really, the idea is not new, but the way people are going after them is what's new. And if you go to the next slide, what we're finding is that, a lot of these breaches don't just come from a bug. Obviously, there are bugs, and that leads to vulnerability that's sometimes exploited. But if you look at, different breaches, and, I think the headline banner case is, Target and some of the costs, these are, significant breaches with big cost, and not only cost in sort of cleanup and recovery and take care of your customers, but also the cost of downtime. If you look at some of the breaches like Sony and such, you have a production-facing network that goes down because of the breach, and then you turn off that customer engagement, that revenue. So there's also a cost of downtime. But these holes aren't just the vulnerabilities that organizations are trying to get at with a secure development lifecycle. These are vulnerabilities in products, in systems, the way they come together, and I actually even argue it's vulnerabilities in people, what some of the people in your organization do. So as you think about building security into your network, this idea of a life cycle, which is somewhat a parallel structure to a secure development life cycle, really has an opportunity to cut some of the breach costs, cut some of the downtime, just in changing sort of how you think about security. Go to the next slide, please. And there's many surveys out there, obviously, on sort of what happens, but this one was a particular one last year, the cost of the breach that Ponemon does, and they do a lot of different annual security surveys. But it's interesting to note that, a lot of breaches aren't necessarily caused by just a vulnerability or a bug in software. And in fact, in their survey here, about 30% were a system glitch. So something happened with the system that was unplanned that led to some sort of breach. I talked about that human vulnerability. About 30% of the breaches they examined were actually caused by a human, so that human vulnerability plays, a big role. Again, these two accounting for almost 2/3 of what organizations were facing. So clearly working on taking bugs out of software is helpful, but there's also an opportunity here to think about a life cycle and how could you put that process in place that's actually going to take away some of the risk to your organization, and whether it's a risk of system glitch, human error, or a risk that someone's actually going to launch a malicious attack and go after something based on some sort of vulnerability you have in your environment. So next slide. And instead of sort of putting up a network diagram and trying to think about the network, I thought we would start with a visual that's a little more interesting, at least. And if you think of the network, it's really a high-performance, secure kind of system that you're putting in place for your business. And much like a Formula One race car, it's obviously a very high-performance system that is managed with sort of a life cycle. So to simplify that a bit, if you think about the Red Bull racing team, anytime they're going to introduce any kind of new component into that car, into the system, they're obviously going to do a lot of validation and tests to make sure it's not going to change anything about the performance or the dynamics of that car based on their past history. So a lot of thought process goes into any introduction of change into that environment. But not only that, as they make those changes or configure the car, they do lots of dry runs. They do a lot of practice runs. They're out testing, not in a real race condition, but before the race, modeling the car, understanding how it works, baselining that change, so they know when they come to race day, they'll be ready. So lots of benchmarking and understanding how those systems perform. Now, obviously, as they take this to race day and then they hit the Formula One circuit, on race day, these cars have hundreds of sensors monitoring the car, monitoring the systems. They're looking almost at a live network in that car, any kind of telemetry of the car, the outside conditions, how components are performing, and making real-world changes to optimize the performance of that car. So much like a live network, having sensors and monitoring all the telemetry, they can really optimize how that car performs during race day. And obviously, after the race, they come back to the garage and they look at what performed well, what didn't perform well, and they begin to make changes in components, configurations, and such. And so they sort of start that whole process over by tweaking and optimizing what they've learned from race day. And if you think about your network and keeping it secure, similar to keeping a Formula One race car highly performing, it's a similar model in that you're not going to introduce any changes without testing them. You're not going to introduce them too quickly. You want to have a lot of monitoring, data collection to make sure you really are, in this case, in your network, secure, much like the car is delivering performance. And so I find it to be an interesting parallel to how you might think about your network and how you're securing it through some sort of life cycle. Next slide. Sort of contrast exciting with not so exciting, but in development organizations and rollout, and Michael and others sort of went through some of the the transition we're seeing to more agile model. But organizations are often familiar with a kind of development life cycle it's a waterfall or some sort of progression. And I think the interesting thing here is the one it's very sequential. But if you look at the bottom of this chart, there's a big arrow that says time. And I think for most organizations, that meant they had lots of time. The left to the right arrow might be months, it could be years, but in general, historically, it's been a very, very long time frame to do some of these life cycle kind of events in the network. So you begin thinking about a change, and it may take, you may not roll out the change for another year. I think that's really changing, and again, Michael mentioned some of the agile development, how that's changing this. This time horizon across the bottom is very, very dramatically changing for most organizations, particularly not only in software development, but also how they roll out changes and manage the infrastructure, which is their network and the security that's attached to that. So next slide. So if you're operating sort of with that frame of reference, you may operate with sort of this frame of reference. Most folks have been to an air show, and they're somewhat familiar with the Blue Angels in the U.S. But this is the plane that the Blue Angels started flying when they were founded back in 1946. It's a F-6F Hellcat, and it was the first, sort of aerobatic performance plane they used when they were founded in Pensacola, Florida. And the kind of maneuvers they did were fairly simple formations, and actually, given their founding right after World War II, probably their biggest performance was a simulated a dogfight with a Japanese fighter. So from a performance perspective, the plane had roughly 2,000 horsepower, top speed of around 380 miles per hour, could fly, gain altitude at a whopping 3,500 feet per minute. So it would take this plane about 7.5 minutes to get to 20,000 feet. But it was a sort of state-of-the-art plane for the Blue Angels when they were founded in 1946. And so if you're thinking about the development life cycle and a life cycle for your network, sort of this is the old way of thinking, and then the waterfall chart we talked about. Next slide. So if you fast forward to the future, this is actually the plane the Blue Angels fly today. It's an FA-18 Hornet. They actually adopted this plane in 1986, so 40 years after their founding. They moved on to a much different plane, obviously much faster. It's a twin-engine, supersonic capable plane. It flies at about Mach 8, 1.8, which is about 1,190 miles per hour. It can climb 5,000 feet per minute, or 50,000 feet per minute. So this plane obviously is going to climb to 50,000 feet in 1/7 the time of where the Blue Angels started. You can see the dramatic change that the Blue Angels have faced in this amount of time. And if you look at sort of what you're facing in trying to manage your network, I think you've got a similar rate of change going on with your environment, whether it's virtualization, mobility, and lots of new technologies being introduced. Next slide. But a big thing you're facing that Michael talked about is this move to DevOps, and everything's speeding up. So much like these planes are speeding up, you're in an organization faced with going faster. This agile development and ability to meet the business demands for speed are forcing this idea of continuous development. So you're continuously rolling out new software very, very rapidly, which, if you think about sort of the race car analogy, creates opportunity to really impact security potentially in a negative way. And one of the organizations that's done a lot of research in this area is Puppet Labs around DevOps. And last year in their annual survey, they found that high-performing organizations can deploy code 30 times more frequently with 50% fewer failures. And so what they're finding is people get really good at this, and they can actually go fast, but they're not experiencing the kind of failures that one might expect if they go fast. And in fact, if you look at the look up the continuous rollout Wikipedia, they say, quote, developers used to a long time cycle may need to change their mindset when working in a continuous development environment. And I think this change that several speakers have all talked about today is creating tremendous challenges for organizations, not only on the software development side, but how they manage the security on the network and roll out changes for that environment. Next slide. So I wanted to introduce some thinking around your network and how you can think about securing that network through its life cycle, because much like the Formula One race car example we talked about, you do go through different stages and need to think differently for each of those. So for instance, when you're in the sort of pre-deployment phase, you've got to figure out, are things going to work? Is this going to do what I think it'll do? Do these devices perform like I think they will? As you actually, move into sort of putting the car on the track, is it configured correctly? Is this going to do what I think it will do? Will I get the security I'm expecting? Will I get the performance? Is their architecture going to work like I think it should? But then also, as you move into that sort of production phase, much like it's important in a Formula One race car to have telemetry data and visibility to what's happening, it's critical in the security environment to have good visibility in what's happening. And in that fourth phase, critically important, and one that a lot of organizations forget about, is, well, what happens as we make changes? How will those changes impact my security, my performance? And so we'll walk through each of these in a little more detail, but I'd like to part that sort of life cycle thinking about the network. So as earlier speakers have talked about developing software and some of the good benchmarks and practices, here's a good way to think about your network as it moves through this life cycle. So next slide. So clearly one of the first questions when you're looking at this life cycle is, does the solution work? you're looking to put in place some sort of product or systems. Perhaps you're building a proof of concept, layering in a couple products. You want to really understand, are the products that I'm selecting going to work as I think they will? Performance and security have a pretty related trade-off, and so lots of security sometimes impacts performance, but yet I need performance in the business. And so, it's important to characterize, for instance, a next-gen firewall. As we've moved into the phase of deploying next-gen firewalls, they do a tremendous amount of application inspection, content inspection. Their behavior in a real-world scenario is going to dramatically differ from sort of application mix to application mix. And so as organizations are picking that kind of device, it's important to do some real-world characterization with loads, and also begin to look at things like evasion techniques and making sure that that device is going to remain resilient as you put it into your real-world network. But also thinking about things like load balancing and failover. You're putting security in some mission-critical networks where you're delivering customer-facing services. It's important to make sure that the architecture you've built for failover or resiliency is going to perform as you expect it will when one of those devices fail or something. And so, obviously, focus here is really, picking devices and making sure that they're going to perform like you think they will before you actually put them in that real-life network. So much like a Formula One race car, any new technology you're introducing, you definitely want to characterize it and understand it before you put it in place. And I think here it's, it's difficult to make these decisions. Often vendors have data sheets and third-party lab reports, but those things are often done in environments that are tailored or somewhat generic to test lots of products or maybe make that product perform in its best light. When you put that product into your network, really understanding that security performance trade-off I touched on is extremely critical for this first phase of the life cycle. Next slide. And again, much like before you put the car on the track, before you actually turn things up in the network, as you go through this installation and commissioning kind of phase, you want to make sure that the architecture is validated and it works like you think it will. I've put pieces together. Is this really going to perform like I expect it to perform based on my design? But also understand some baselines of how you think it's going to perform, so as you go live, you can measure performance against that or any kind of gaps. But also thinking about the visibility that you're going to need for security monitoring as you move forward. Where is traffic moving? Where do I need to see that traffic? Often, in sort of this phase of installing and commissioning, without some thought and planning, you might actually begin to lose visibility for some of the traffic you may need to see for compliance or audit monitoring or some sort of threat analysis. And so the introduction of things like virtualization can greatly change your ability to see that traffic for monitoring. So in this installing and commissioning phase, you want to consider things like virtualization. And so, for instance, an activity that an organization might pursue here is you built a DDoS mitigation strategy. So perhaps you have some products on premises in your network to do some application identification for DDoS mitigation, some application-based attacks or even floods. Maybe you have a scrubbing service in the cloud and a combination of the two, but is that really going to work under a live attack like you expect it to? So in this phase, you might do things like conduct a DDoS mitigation readiness exercise to understand, did the product perform in my network? Did the cloud service work as I expected? And even more importantly, did my team communicate with one another and with some of the service providers so that we got maximum effectiveness trying to mitigate that DDoS attack when it hit the network? So in this phase, you're like we said, getting ready to put the car on the track, but really going through and looking at the network and how's it going to perform when I go live. Next slide. So we talked about, sort of getting ready for the race, to use that analogy, but in the production phase, it's extremely important to have that visibility that I talked about earlier. More and more, one is we're being challenged to get visibility to traffic with virtualization and other things, but also the quantities of data are really beginning to stress some of the products that you're trying to put into network. So if you've got monitoring tools that are either looking at doing threat analysis, or you've got other monitoring tools that are doing capture for logging, audit, or compliance, just the sheer amounts of data you're seeing make it challenging to optimize those product deployments. So you have to think about, well, how can I load balance these high rates of traffic flows across devices, or how can I potentially get some of these products deployed in line where I may need additional instrumentation to manage those devices. And so there's a tremendous amount of data being created on the network, and with the talk about using some of this data to look at things like indicators of compromise, it becomes important to put more intelligence around that data. Also to begin looking not just at the raw traffic, but to look into the applications and get some intelligence on what's moving across my network. Maybe there's applications that are applications I don't want to allow due to the risk profile, or maybe they're coming from parts of the world where there's a higher risk. I want to understand that. So the richness of the monitoring of your production network is really required to get some of this security visibility, whether it's for SIM tools, logging tools, or just understanding that risk profile and what's actually happening on the network. And in fact, one of the guys at Forrester Research talk about building out a data acquisition network, and they talk about the strategic importance of that, because it's that data moving around the network that is super beneficial in your security efforts and doing some risk management, because often it's not the alarm going off that tells you something's happened. It's some of this data that might be surfaced through very effective visibility and monitoring from a data acquisition network, or pulling it together, that's going to help you see something that's happening on the network and maybe give you an early warning or advance notice that there's some sort of breach or something happening on your network. And so this is very much, during the race kind of analogy of you're monitoring all the telemetry and how that car is performing. You want to be doing the same for security in your network, understanding what's happening and also optimizing all the security products that you put in place. So this final phase is the one that often is overlooked, and are you testing changes? Great organizations put a lot of time and focus on introducing new things into their environment, testing them, validating, making a vendor selection, building a proof of concept. Then once those things roll into the environment, sometimes there's not as much focus on the change management that happens as devices change and evolve. So your security device gets a new signature update, or maybe a more significant a version, a dot release of a software that's going into a hardware platform. Are you thinking about those and validating them, given the same sort of scrutiny that you do when you first roll those out onto your network? If you go back to the earlier chart we shared on the Ponemon study, remember, a third of those breaches, roughly a third, were system glitches, and roughly a third were human errors. This is a place where testing changes is probably going to reduce some of those human and system glitch errors, but also I would argue it might actually address some of those vulnerabilities. If you look at a good example is the testing that NSS Labs does. They test vendor products, do a snapshot, and publish those test results. Very thorough, I would say a very objective, sort of test benchmark of their security effectiveness. In the recent 8 months, in one of those cycles, they retested a product. In this case, it was a next-gen firewall product. That retest, the product actually failed some of its detection invasion techniques and scored much lower than a prior version. And through the analysis that was done between the vendor and NSS, what came to be found was the vendor had actually changed the software, published a new version. But in that new version, some of the things they had done to optimize performance and use caching, different algorithms, had actually affected the security effectiveness or some of the evasion techniques. And so it's I highlight that as an example of, even though you take a snapshot, you test a product, security product in particular, before it's introduced in your network, these things can change over time. And when that happens, you may actually now be weakening your sort of threat defenses or weakening your security resilience by introducing a change in there. So it's important to sort of continue monitoring this configuration drift or changes and doing some of that same real-world testing that you did at phase 1, because also your application mix is changing. Your use of mobile devices is changing, so you constantly keep updating these test configurations to really deal with the real world. So we talked about a network life cycle and sort of a generic way of dealing with that through kind of an analogy of a Formula One race car. And this is, very much an application of sort of ICSI and the solutions and what we do. Very focused on helping our customers ensure application performance and security resilience. And so making sure that their security is going to perform, stand up to all kind of real-world conditions, but also, perform through that life cycle as you would expect it to, while also delivering application performance. We talked about the trade-off of performance and security. It's important to get that balance right. And so what we do is through a process of our customers doing sort of network design, network rollout, network operation, very much like the life cycle we've been speaking about today, we help our customers through a process of doing validation. So are the things I'm about to introduce into my network going to perform, behave like I think they will? A lot of that's done through testing and test tools that can, create tremendous loads, can create real-world application environments, create real-world in-device environments. And so I have lots of mobile devices I want to test in a very mobile environment, and doing this across both a physical and a virtual environment. So as organizations are concerned about moving or migrating some of their infrastructure to a virtualized infrastructure, you want to continue to do some of that testing for those virtual environments, just like you do for a physical environment. But also, making sure this is secure. So we talked a little bit about the testing of security devices, but doing the assessment and an ongoing monitoring of threats against some of these real-world scenarios. And so I'm making sure that the devices I'm rolling out into the network are very security resilient, are going to stand up to attacks, but also making sure that I can monitor threats and optimize the data flow or traffic flow to a lot of the other security tools that I may have in my network, and give them that visibility into virtualized traffic or east-west traffic, things where I may have difficulty maintaining some of that security visibility. And then ongoing sort of optimizing the whole process. Things change, and optimizing the configuration so that you get the application performance with the security you're looking at across the entire network. So from an Ixia perspective, really focus on helping our customers do this primarily through a set of products and solutions with some of the professional services. Next slide. So some of the things we do, this wasn't meant to sort of drill down to some of the products, but for instance, in testing some of this, we have dedicated products like Breaking Point, which is a software platform that can run on dedicated hardware, can run in a virtual machine that actually does this real-world testing of security and applications. And so creating, tremendous loads, creating real-world mixes of traffic, and then injecting the kind of attacks you're going to face, trying to run evasion techniques, using fuzzing, to really make sure that that device or even a security system is going to perform, have that resiliency, have that failover kind of hardness that you're trying to put in place in your network. So really sort of validating and testing your security, but also giving you the insights into some of the intelligence and the data flows that you need. So having the visibility to get the right traffic to your SIM tool or to a third-party auditing compliance tool, or even a performance management tool where you're trying to feed lots of data. So getting that traffic there via taps, packet brokers, being able to put the instrument in place in the network so you maintain that visibility, but also having the ability to deploy security products with resilience. And so often putting the security product in place, we talked about that fourth change of a life cycle. I have to introduce change, have to take that device out of the line. Often there's a need for some sort of bypass switch or sort of visibility technologies to put some of these security products in place, so I have that resiliency ongoing. And even some of the scenarios are, I talked about a DDoS mitigation sort of exercise, even doing sort of cyber range or cyber exercises where some of these products you can actually put your team through exercises to make sure that they know how to react and work with your SIM product, or what happens when you have a large attack happening. How do they actually work with the security infrastructure and some of the communications? Another use case that many customers go after in pursuing some of that life cycle. So in many ways, Ixia doesn't build a lot of the inline security products you may think of, like next-gen firewalls or DLP or firewalls or IPS, but through our test and visibility solutions, we actually make sure those products have security resilience, they're going to work in your environment, and you can deploy them and maintain visibility so that they're very, very effective. And so that helps you tremendously with that life cycle that's going to help you reduce some of your risk and make your security much more effective. Next slide. So I talked about the life cycle. There's actually a great ebook reference that goes into a lot of detail If you're interested in reading more, it goes through many more detailed examples than some of the ones I highlighted. You can get that from our website. Go to our website. You'll see a link to download the ebook on how to secure your network through its life cycle. I believe also in some of the follow-up email conversations from today's session, you'll also see a link to download that. So a great resource to sort of think about this life cycle. And there's probably things there that you could think about and begin to embrace for managing your own network through the security life cycle. So with that, George, I'll hand it back to you.
Thank you. And once again, you can submit questions on the top right of the GoToWebinar control panel. We have a few questions, so we'll get started going through some of these. First, for Fred, what is the most important benefit of the life cycle approach? I know you've mentioned a few, and most speakers have as well. But what do you see as the biggest benefit to this life cycle approach?
Yeah, so I think two things. One, I think one, it gets an organization connected. So if you think about that life cycle, probably most of the attendees are thinking their organization. There's different people involved in different parts of that. So I think it helps drive an integration across different functions and sort of thinking this way, across an organization. So I think that communication organization is important. But also I think it gets organizations thinking about a process so that their different security efforts are more connected. So not only the communication part, but thinking change we do over here, how's it going to affect something else? So I think really that interconnectedness that it brings to a whole bigger picture. I don't like to use the word holistic, but sort of looking at all those pieces integrated with the bigger picture, I think is hugely beneficial.
Excellent, thank you. Once again, you could submit questions. We can now go on to an open discussion where we encourage everyone in the audience to submit questions. We have a few questions here that have already been submitted, and we thank you for submitting those. We will start with a very good question here that says, should newly developed software or even infrastructure be tested while in isolation mode or while in production or test environments? I think Michael, we'll start with you.
Sure. Okay, maybe I spend too much time with lawyers. It depends. It depends on what the software is that you're doing. Is it for your entire organization? Is it to go outside the organization? One of the things that I found the most useful when I start up an SDL someplace is have lunch and learns. Teach people the basics and the foundation of developing secure code. Explain the issue or the potential issue. The reason I said it depends is some people want to go straight to running a pen test or a penetration test on their software or their infrastructure, and unfortunately they find themselves in trouble with the information technology team, the guys who run the infrastructure, or the legal department, because what happens if the pen test succeeds and you crash your system, or you destroy something, or you exfiltrate something that you're not supposed to. So it's always good to have them appraised of it as well. But if you're just doing the startup and getting people to think about security, the best way to do it is clearly lunch and learns. And there are a number of sites. The Department of Homeland Security has an entire training class online. There's stuff from OWASP and MITRE, etc. And if you're looking at the network, the book that Fred just pointed at is an excellent resource as well.
Excellent, thank you. I think Fred has something to add here as well.
Yeah, George. I think actually we get that question a lot from our customers because, of course, with a product called Breaking Point, this question comes to mind quickly. But can I do some of this? I want to understand my real live network, but I'm concerned with, much like Michael said, you run a pen test on your real network, you might knock things over and be disruptive. And so, we hear a lot of that. Do I do some live network or production network, or live production network, or some sort of other network? And a lot of organizations, if they have some sort of critical infrastructure that's used to deliver services to a customer, that they have a lab or they've got a staged area where they stage changes and such. And so, what we find is it's possible to really do a very good job of mimicking the real world. It's not just running generic TCP/IP traffic or floods that are stateless or something. You can actually create real world application flows. You can mimic a mobile device, the device, the application. you can create these real-world conditions such that even though it's in a staged lab, it looks so much like your real-life production network that you get that benefit of sort of testing with production kind of conditions. And so that's what most of our customers do, is they strive to build that real-world test capabilities off their production network. There's some cases where you might do something on a production network. Maybe you have service windows over the weekend or something. We've had clients do DDoS mitigation testing off hours, but it's tricky.
Excellent. So this, I guess, kind of goes into something that you already answered, but it was a question that was asked. So we'll reiterate, and it says, my company doesn't have a software auditing or quality assurance team. What are some just suggestions on how to start the process on SDLC? So I know we answered this particularly for other companies, but there's really no starting point here, right? There is no software auditing, no other team that does QA. Would the same suggestion of starting with lunch and learns and that apply here, or do you have any other thoughts on that? And of course, I'd like to open it up to Harry as well.
So starting with my recommendation, starting slow, like developers doing their own security testing and building up the database, kind of issues they find, and probably invite other developers for peer code reviews, and going from there. That would be a great start, and then they can go in. Dive into making a formal policies and following those policies.
Excellent.
So yeah, I've actually seen a lot of this as well. Usually it comes about at the end of failing an audit. Unfortunately, someone will come in and want to audit, or you'll be up for a bid and they'll want to do a review of stuff. So yeah, it's kind of tough. You want to definitely do a lunch and learn or something at the beginning to get people thinking, and just be prepared.
So Michael, this was a question that came in right after you spoke, and the question is, can you explain a little more about the mitigations that you talked about in the presentation?
Well, it depends on the threat. So, for example, information leakage, there are standards of mitigation that you apply. If it's information leakage against communications, IPsec, or, and I've got to say this even after last week's announcements with OpenSSL, so that you're protecting the communication channel from leaking or being visible from the outside, or from being tampered, because it is encrypted and it's point-to-point. If I'm looking at denial of service, I usually pass denial of service off to the hardware and the configuration of the system and infrastructure. If someone's breaking into your machine and it's on your corporate network, or they're shutting your machine down and it's on the corporate network, your corporation has other issues to worry about. But fault tolerance is typically what I look for there, or scalability. So it all depends on what the threat is to map to the mitigation, or the mitigation to map to the threat. And there are standard ones, like I said.
Excellent. Harry or Fred, anything to add on this particular question related to mitigations?
No, I think one thing that we find our customers do is often these things happen quickly. Putting mitigations in place, and so when there's a we talked about OpenSSL vulnerabilities a little bit today, but there's pick the issue, and there's usually kind of a rapid pace of vendor updating something, pushing out either one of two things. Either the vendor's pushing out a new update to their product that's going to fix the vulnerability, or on the flip side, you have a security vendor pushing out some sort of mitigation. So, hey, here's my new signature. This is going to detect this and prevent this, OpenSSL exploit or Poodle, or go back in time. So organizations are faced with, okay, I'm running to qualify a change, put it in place, make sure it works, but also I've got this mitigating update I want to introduce. And we talked about a Lifecycle today and making changes, so now I've got two changes to think about. And so, again, many organizations, our customers, they have the capacity to say, okay, well, I've got the mitigation from a security vendor. I want to test that to see how effective it will be. So they can quickly get an assessment of, by running what we call strikes. And so when there's a vulnerability, or we write an offensive kind of attack, we call it a strike. And so they can run these strikes against that mitigating update from a vendor and understand how much is it going to reduce the risk profile they're going to be exploited, because sometimes signatures don't cover everything. You can really quickly understand that. Or if you do have the update for your infrastructure and you're trying to push that, we can also test that to make sure that that the patch that the vendor is giving you to fix the underlying vulnerability is truly fixed, and either it's going to fix it, or you've got your mitigation in place to defend it. And so so it becomes an important step in sort of that life cycle of rolling out changes, whether it's a vendor patch or some sort of mitigating signature update or something to deal with these environments that Michael is commenting on.
Great, thank you, Fred. We have another excellent question here. Is there any kind of certification of SDLC practices, something like Common Carrier or something like that? We could go to Michael.
So Common Criteria is, I'm not sure what Common Carrier is, but I'm assuming it might be Common Criteria. Common Criteria is about, tell me what you did for security in a specific area and let me know how you did it, and then we just validate that you did it the way you said. I haven't seen anything that actually looks at the code per se that says, yes, this is a good housekeeping seal of approval. But what I have seen is the Certified Secure Software Lifecycle Professional, CSSLP, which basically says that the person working on software or doing your software, in theory, knows how to do secure software. Just got to be careful. Sometimes we tend to pay too much attention to these certifications and not what people have done. But that's the closest thing I've seen to a certification for digital products go through a good life cycle. Anyone else want to comment?
Thank you, Michael. No, I think that was a good answer. I'm having another question. We're kind of related to this. Are there any guidelines or any federal or regulatory requirements for SDLC?
There may be some stuff consumed in SP 800-53 that might be interesting for it, but that's the only thing I've seen that would be a requirement for it at the federal level. But also remember, there might also be some international stuff as well, but I haven't paid attention to those.
Okay, excellent. This question came during Fred's talk, and it's, so you are saying that lifecycle approach will prevent a breach?
Well, not actually. Actually, I think that's an interesting question. I mean, I think any security vendor or security solutions pitch is, hey, is actually going to, absolutely prevent a breach. Back to some of Michael's comments, I might need to bring in the lawyers and such. So no, I don't think we were saying, it's absolutely positively going to prevent a breach. But I think, if an organization's thinking about how they secure their network through that life cycle, I think they're going to, one, have much more effective security and overall have, much greater security resilience to the kind of attacks, whether they're going after vulnerabilities or human errors that we talked about. It's a great exercise in risk reduction. So I think you're greatly lessening the chance that you're going to experience a breach. It's difficult to drive that number to zero, but you're greatly going to reduce that attack surface due to the way you deploy products, the way you test them, how you're introducing change into your environment, and then retesting it. So it definitely reduces the risk. I think the other thing, a good life cycle process is probably also going to reduce some of the cost and time for security, because you're going to be able to deploy things probably more faster with confidence. You might actually be able to right-size products more effectively because you've really characterized them. Even that back-end change management, you're going to take some cost out. So I think there's probably also a cost advantage there.
Excellent. All right. I don't see any other questions coming in. We're right around 1:30 Eastern Daylight Time, so I'll take this time to thank you all for participating in our ISSA web conference, and thank you for the excellent questions. I would also like to thank today's speakers, Michael, Harry, and Fred, for lending their time and expertise to this ISSA educational program. I will now turn it over to Valerie for closing remarks and final thank you.
We would like to thank ICSIA for generously supporting this web conference. We also thank Citrix for donating the GoToWebinar service to ISSA, allowing us to present this program today. Please feel free to continue the conversations on ISSA social media sites, LinkedIn, Facebook, Twitter, and Google+. Within 24 hours of the conclusion of this webcast, you will receive a follow-up email which contains information on the web conference quiz. After the successful completion of the quiz, you will be given an opportunity to print a certificate of attendance to use for the submission of CPE credits. Thank you again for your time and participation. This concludes today's broadcast.